morning, everybody. Now we are moving to the discussion of design of general bearing in the way of some numerical calculations and designs. For that, the selection of SAE oil is very important. That information is available in this table. SAE in the form of SAE 10, 20, 30, 40, 50, 60, 70, ranging from temperature value of operating temperature 30 to say 90 degrees centigrade. This is one of the typical design data table for lubricating oil for various versions of viscosity. SAE, as you know, you may be knowing the full form of SAE, Society of Automotive Engines. There are fixed some grades. So as the grade increases, it will be very clear that viscosity value will be increasing. Again, for the same lubricating oil selected, as the temperature increases, as you know from the basic science, the viscosity value will be decreasing. This is called bearing characteristic number. How to get the bearing characteristic number is a terminology normally using during the design of the general bearing. So in this slide we can see that the coefficient of friction mu is related with three parameters: Zn by P, d by C and L by D, where Z is the viscosity, N is the speed, P is the allowable pressure. D is the diameter of channel, C is the clearance, L is the length of channel. And so it's very important information that mu is related with the three parameters: Zn by P, D by C and L by D. And normally it is already derived an equation, empirical relation for mu, which is available in the data book, connecting three parameters: Zn by P, D by C and L by D. This graph will give you a better idea how the Zn by P value varies with respect to the coefficient of friction, because I told you the viscosity value is related with the Zn by P, L by D, D by C values. Where Zn by P is called you can see the variation in this graph. Zn by P is termed as the bearing characteristic number and is dimensionless number. The variation of coefficient of friction with operating values of Zn by P is shown in the figure. So this Zn by P is very important during the design because that is called bearing characteristic number, and three segments are shown here. Three segments you see. This is the first segment. This is the second segment. This is the third segment. Here the viscosity value will be very minimum, so that area is called boundary lubrication area. Second area, as the Zn by P increases, that zone is called partial lubrication. And the third one, again the Zn by P value increases, that region is called film lubrication area. So during the lubrication, with respect to the bearing characteristic number in all bearings, scientifically we can predict three areas: boundary lubrication time, partial lubrication time and film lubrication time. Because as it operates, the Zn by P value may changes because speed is constant. Z may vary based on the temperature. P, allowable pressure, is also fixed. Coefficient of friction in that way is also changes with respect to the operating conditions. So as therefore the variation of mu with respect to the Zn by P is located in the form of three regions: either boundary layer lubrication or partial lubrication or film lubrications. Same figure because we have made more clear. Coefficient of friction therefore is already derived based on the basic science. So we already shown you the relation, how it varies. So therefore the one empirical relation is already available. Mu is equal to 33 by 10 raised to 10 into Zn by P into D by C plus K, where K is called factor to correct the end leakage. That range value is given to 0.002 for L by D, ratio of 0.75 to 2.8. So you can substitute in this equation. Mu is, how to calculate mu is very simple. 33 by 10 raised to 10 set done by P. That is a bearing characteristic number. You can select as a full parameter or individually. Set, if you set is given and n is given, P is given, you can calculate set done by P. Otherwise, you can combine these three terms together. That selection also possible. D is the diameter will be given. C you have to select from the data book. K also you can select from this arbitrary range 0.002 for L by D ratio 0.75 to 2.8. If L by D ratio is not coming in this range, you have to refer the data book. So this is the way of calculation of viscosity during the design of a journal earring.